Hey, how's it going, guys? Happy Thursday. So yesterday we took a look at the tricycle races, didn't we? And today, now that we're on to the main event, we have the final race. So remember yesterday's activity, we were talking about heats of races, and so like you might have 40 people trying to run the same race, so you're going to have them race 4 times each to try and get the top 2 from each race, so that way the top contenders can run at the end of it, similar to the way that like the Olympics worked for the 100-meter and 200-meter dash that we watched Usain Bolt do yesterday. But anyways, what we're going to do today is there is a document linked in Google Classroom to this assignment, as well as on the very next screen, that is going to give you the details for myself, Ms. Jones, Mr. Wade, and Ms. Ogletree's racing skills, or the rates at which we moved and what kind of head starts we got, alongside Elizabeth and Leslie, who we dealt with yesterday. So without further ado, I'm going to walk you guys through a couple of examples that are actually going to be the answers to a couple of the next slides right here, right now, so we can figure out who the big winner is. So first things first, I want to start with Elizabeth, all right? I want to take a look at what her equation would be for her distance versus time graph. So it says that Elizabeth is 11 meters into the race after 4 seconds, but is only 13 meters into the race after 12 seconds. So it looks like we have pairs of x values and pairs of y values, don't we? And remember, our y-axis for these graphs is distance and our x values is time. So if we take a look, the change in y, we went from 11 meters to 13 meters, so my difference is 13 minus 11. And then that was from 12 seconds, well, between 4 and 12 seconds. So we got to do 12 minus 4. And so it looks like we went 2 meters in 8 seconds. So our rate of change, or our slope, would be 2/8, which can simplify to being 1/4. So our equation would be y equals 1/4 x. But what's the y-intercept? Well, it says that she's 11 meters into the race after 4 seconds. So if she's only moving 1 meter every 4 seconds that we know of based off of the slope, so 1 meter every 4 seconds, and she's 11 meters into the race after 4 seconds, then that means that she's only a meter away from her starting position. So if we take a look at that, if after 4 seconds she was there in 11 meters and we go backwards 4 seconds, that means that she started out at 10 meters. So the equation for her line is y equals 1/4 x plus 10. And this means that she's riding at 1 meter every 4 seconds and had a head start of 10 meters. Now, let's go ahead and take a look at Ms. Jones. I'm going to highlight her cell in pink. So it says that Ms. Jones gets the same head start as Elizabeth, but rides 1 meter every 2 seconds. So for Ms. Jones, same head start as Elizabeth. So I already know if I'm going to write y equals something times x plus or minus something, if she's got the same head start as Elizabeth, then she's got the 10-meter head start that Elizabeth had. So with a head start of 10, it looks like we only need to find the slope. But in here it says that she rides 1 meter every 2 seconds. So if our change in y over change in x is our slope, and our y values are the meters and our x values is time, then that means that 1 meter every 2 seconds is our slope. So 1 over 2. We're traveling 1 meter every 2 seconds. So our slope is 1/2, meaning every time that we increase the time by 1 second, we're traveling 1/2 meter. Every single time that I've traveled a full meter, 2 seconds have elapsed. So our slope is going to be 1 meter every 2 seconds, and our head start is 10. And our equation is y equals 1/2 x plus 10. Now, let's go ahead and take a look at Mr. Wade. So it says that Mr. Wade rides half as fast as Leslie, but he's going to get a 4-meter head start. So if we look at Leslie's race, it says that she rode 2 meters per second. So if he's riding half as fast as Leslie, and Leslie's going 2 meters per second, that means that Mr. Wade's only going 4 meters per second. I mean, he's only going 1 meter per second, because half of 2 is 1. So if she's riding 2 meters per second, then that means that Mr. Wade is riding 1 meter per second. So if we start writing Mr. Wade's equation here, we've got y equals 1 meter per 1 second times x, which is just 1 over 1. So in reality, we can just write that as y equals x. And then it says that he got a 4 meter head start. So the equation for Mr. Wade is y equals x plus 4, where we know he's traveling 1 meter. He's traveling 1 meter per 1 second and has a head start of 4. So now that we know that his equation is y equals x plus 4, and you guys can go ahead and select that, what I need you to do is go to answer and select those equations in the following screens, and then you're going to try and figure out the equation that models my race, as well as the equation that models Ms. Ogletree's race. And then you're going to try and find out the equation that models Leslie's race using all of the information that's in the table for screen 6, which is also linked in the document for this assignment. Then on screen 10, I want you to go ahead and graph the lines of each racer. I've already put Mr. Wade's and Ms. Jones' equations in there. So you need to graph Elizabeth's, mine, Ms. Ogletree's, and Leslie's lines. That way you can answer the questions on slide 11 and 12. So remember, to graph in Desmos, you're going to click in that little table on the left side, and you're going to just begin to type in y equals, then you can type in the slope times x plus the value from your y-intercept to graph those 4 lines. And then you can zoom in or zoom out to answer the question that if the race was 25 meters long, who won? And if the race was 25 meters long, who got last place? So you'll use the graph that you make. I've already given you 3 of the equations, and I've graphed 2 of them. So you need to find the other 3 equations and graph 4 of them, and then you should be able to answer those 2 questions. And that's all I've got for you today. As always, I'm going to have my office hours from 3 to 3:30 p.m. today. So if you have any questions, stop in there, and I'd be more than happy to help. Anyways, best of luck. Have a good one.